Hello and welcome to Principles of Sustainability. I'm your instructor, Brett Ketter. In this course, we will discuss the numerous aspects of sustainability from its origins, its various forms, how sustainability is being incorporated, and its reach throughout the country and the rest of the world. So sit back and let's get started. Chapter 1, Roots of the Modern Sustainability Movement. While there are many definitions of sustainability, the one we will go with is this: living within the bounds of nature based on renewable resources used in ways that won't deplete non renewable resources, harm essential ecological services, or limit the ability of future generations to meet their own needs. There's a lot that can be discussed as to how to define sustainability. However, there are also the personal side of that definition that people often incorporate. The question often becomes, how can I make my life more sustainable? We will cover more of this as we go through this course. Sustainability is encompassed by the three E's, that being the environment, economics, and equity. Each of these is essential to making a positive impact on a sustainable future. While most people associate sustainability with the environment, there needs to be a conscious decision on a businesses or governments to incorporate these facets of sustainability into their decision making in order to fully achieve a sustainable future. Many people have made changes to their everyday life to become more sustainable. However, if businesses don't follow suit, little headway is made. The same applies to governments, where decisions involving equity can drastically create a better future for its citizens with an eye on the sustainable future. As we will see throughout this course, governments far too often don't always have its citizens' best interests at heart when making decisions when it comes to sustainability. There are many different definitions of sustainability depending on who is using it. In these terms, it is usually something that can be capable of being continued indefinitely. In sports, sustainability is often used as a measure of endurance or a level of competitiveness, such as a running back football player who has a run of games with over 100 yards per game. Announcers will often say such things as, he's on a great streak, but is that sustainable over a full season of football? Fast growth or steep profits are often questioned as to their sustainability in the business world. Some companies grow very fast at the beginning, but over time begin to plateau or even decline. In personal relationships are often measured in terms of their sustainability, being that some are often doomed to fail if there are extreme factors in place, such as drug or alcohol dependency, economic factors, etc. Let's do a shallow dip into a much deeper pool that is the history of sustainability. While there is no definitive history of when it all started, we know that Native Americans practiced sustainable lifestyles in many facets of their culture. This includes land and game management because of their livelihood depended on it. As early as 1769, there was evidence that the French governor of the Mauritius Islands ordered a quarter of the land to be protected from overlogging and animal protection, such as the dodo bird, which ultimately went extinct. Were several key figures in America that paved the way for looking at the practice of sustainability to help preserve and conserve areas for future generations to enjoy. John Muir moved to Wisconsin when he was a child, and as an adult began to see that there were areas of Wisconsin and later other areas of the United States that should be protected. Muir was noted for being an ecological thinker, political spokesman, and environmental advocate whose writings became a personal guide into nature for many people, making his name almost ubiquitous in the modern environmental consciousness. His letters, essays, and books describing his adventures in nature, especially in the Sierra Nevada of California, have been read by millions. His activism helped to preserve the Yosemite Valley and Sequoia National Park, and his example has served as an inspiration for the preservation of many other wilderness areas. The Sierra Club, which he co-founded, is a prominent American conservation organization. In his later life, Muir devoted most of his time to the preservation of the western forests. Conservation in the United States began as a movement to save the country's vanishing forests and the variety of resources within them. But over time, the concept broadened. Many environmental groups formed to lobby to the government and help bring about necessary changes. The reasonable use of the Earth's natural resources is the focus of conservation to maintain the environment, to meet the human needs while ensuring consideration for aesthetics, wildlife, and recreation. Timber, fuels, and ores have been and still are being depleted so rapidly that the need to conserve them has become crucial. Conservation seeks to prevent the waste of natural resources, control pollution, and maintain a quality environment for future generations. Among the most valuable of these resources are forests, holding watersheds essential to water and soil conservation. They shelter many forms of wildlife, contain landscapes of incredible beauty, supply lumber for construction, cordwood for fuel, and pulp for paper. Forests also provide the raw materials used in many synthetic products considered essential for modern life, including fibers, plastics, and medicines. By 1885, the year Gifford Pinchot decided upon a career in forestry, much of the eastern forests had been burned to create farmlands, plundered of wood for construction and fuel, and in many cases wasted away through carelessness. Although many people were concerned with the destruction of America's forests and resources, newly elected President Theodore Roosevelt would serve as a catalyst to action. The conservation movement had begun. Roosevelt would lead the charge, and Gifford Pinchot, his chief forester, would take the heat. Conservation never has been an easy sell. The word itself is confusing. Many incorrectly think of it as preservation, to save everything undisturbed. Pinchot and Roosevelt defined it as the wise use of Earth's natural resources so that renewable ones like timber could regenerate and non-renewable ones like coal could be prudently utilized to last as long as possible. The idea was to scientifically manage natural resources for the present and the future. Later, under Franklin D. Roosevelt, the Civilian Conservation Corps and the Soil Conservation Service implemented reforestation and erosion control to combat a severe drought in the Plains states. The Taylor Grazing Act of 1934 regulated livestock on public lands to prevent overgrazing and soil deterioration. Later, President Harry S. Truman began a national program to control water pollution. Later legislation required states to set standards for clean natural waters. Efforts to save native wildlife from extinction were aided by the Endangered Species Preservation Act of 1966. The National Environment Policy Act of 1970, a far-reaching measure and supported by President Richard M. Nixon, emphasized recycling and advocated attempts to equalize population and resource use. In 1970, the Environmental Protection Agency was formed to promote and enforce environmental quality. Also in 1970, the Greenpeace Foundation was established with special emphasis against radioactive and toxic waste dumping, nuclear weapons, and acid rain. Finally, in 1990, President George Bush's administration pushed through legislation that amended the Clean Air Act of 1970, putting greater emphasis on reducing acid rain, fossil fuel emissions, and ozone depletion. These are just a few of the sweeping legislation acts that have taken place to help safeguard our natural resources, and they are still being done today. The seeds that grew into the first Earth Day were planted by Wisconsin Senator Gaylord Nelson. An ardent conservationist and former two-term governor of Wisconsin, Nelson had long sought ways to increase the potency of the environment as a political issue. The extraordinary attention garnered by Rachel Carson's 1962 book Silent Spring, the famous 1968 Earthrise NASA photograph of the Earth from the Moon, the saturation news coverage given to the Santa Barbara oil spill, and the Cahoyaga River catching fire in early 1969 led Nelson to think that the time was ripe for an environmental initiative. Nelson chose the date to maximize participation on college campuses for what he conceived as an environmental teach-in. He determined the week of April 19th through the 25th was the best bet as it did not fall during exams or spring breaks. Moreover, it did not conflict with religious holidays such as Easter or Passover, and was late enough in the spring to have decent weather. More students were likely to be in class, and there would be less competition with other midweek events, so he chose Wednesday, April 22nd. Due to the efforts of Senator Nelson and many others, the first Earth Day was held on April 22, 1970, where more than 20 million people poured out into the streets, and the first Earth Day remains the largest single day protest in human history. Aldo Leopold was an American writer, philosopher, naturalist, scientist, ecologist, forester, conservationist, and environmentalist. He was a professor at the University of Wisconsin and is best known for his book, A Sand County Almanac in 1949. By the early 1920s, Leopold had concluded that a particular kind of preservation should be embraced in the national forests of the American West. He was prompted to this by the rampant building of roads to accommodate the proliferation of the automobile and the related increasingly heavy recreational demands placed on public lands. He was the first to employ the term wilderness to describe such preservation. Over the next 2 decades, he added ethical and scientific rationales to his defense of the wilderness concept. Leopold believed that it is easier to maintain wilderness than to create it. By 1930s, Leopold had become one of the first Americans to publish extensively on the startup discipline of wildlife management. He advocated the scientific management of wildlife habitats by both public and private landholders rather than the reliance on game refuges, hunting laws, and other methods intended to protect specific species of desired game. Rachel Louise Carson was an American marine biologist, writer, and conservationist whose influential book Silent Spring, published in 1962, and other writings are credited with advancing the global environment movement. The book described the harmful effects of pesticides on the environment and is widely credited with helping launch the environmental movement. Carson was not the first or the only person to raise concern about the pesticide DDT, but her combination of scientific knowledge and poetic writing reached a broad audience and helped focus opposition to the use of DDT. Carson's main argument is that pesticides have detrimental effects on the environment. They are more properly termed biocides, she argues, because their effects are rarely limited to the target pests. DDT is a prime example, but other synthetic pesticides come under scrutiny, many of which are subject to bioaccumulation, meaning they are stored in the body once ingested. Carson also accuses the chemical industry of intentionally spreading disinformation and public officials of accepting industry claims uncritically. Most of the book is devoted to pesticide effects on natural ecosystems. However, 4 chapters also detail cases of human pesticide poisoning, cancer, and other illnesses attributed to pesticides. Here we see a timeline starting in 1962 with the publishing of Rachel Carlson's book, Silent Spring. As you can see from the graph, there is a significant amount of change that took place in the 60s and 70s when it came to environmental policy. On the graph, those items in green represent significant events that would help influence change in policy. Those items in blue represent huge wins for the environmental movement, including policy changes. And those items in red are environmental disasters that took place from around the world. Ozone depletion consists of two related events observed since the late 70s. A steady lowering of about 4% in total of the ozone in the Earth's atmosphere, and a much larger springtime decrease in the ozone layer around Earth's polar regions, often called the ozone hole. The main causes of ozone depletion and the ozone hole are manufactured chemicals, especially manufactured halocarbon refrigerants, solvents, propellants, and foam blowing agents known as chlorofluorocarbons or CFCs. Ozone depletion and the ozone hole have generated worldwide concern over increased cancer risks and other negative effects. The ozone layer prevents harmful wavelengths of ultraviolet light from passing through the Earth's atmosphere. These wavelengths cause skin cancer, sunburn, permanent blindness, and cataracts, which were projected to increase dramatically as a result of thinning ozone, as well as harming plants and animals. These concerns led to the adoption of the Montreal Protocol in 1987, which bans the production of CFCs, halons, and other ozone-depleting chemicals. The ban came into effect in 1989. Ozone levels stabilized by the mid-90s and began to recover in the 2000s as the shifting of the jet stream in the southern hemisphere towards the South Pole has stopped and might even be reversing. Recovery is projected to continue over the next century, and the ozone hole was expected to reach pre-1980 levels by around 2075. In 2019, NASA reported that the ozone hole was the smallest ever it has been since it was first discovered in 1982. The Brundtland Report was published in October of 1987 by the United Nations and was in recognition of Gro Harlem Brundtland, former Norwegian Prime Minister and chair of the World Commission on Environment and Development. The document was a culmination of a 900-day international exercise which cataloged, analyzed, and synthesized written submissions and expert testimony from senior government representatives, scientists and experts, research institutes, industrialists, representatives of non-governmental organizations, and the general public held at public hearings throughout the world. The report defined sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. The Brundtland Report recognized that human resource development in the form of poverty reduction, gender equity, and wealth redistribution was crucial to formulating strategies for environmental conservation. And it also recognized that environmental limits to economic growth in industrialized and industrializing societies existed. The Brundtland Report claimed that poverty reduces sustainability and accelerates environmental pressures, creating the need for balancing between economy and ecology. In addition, key contributions of the Brundtland Report to the concept of sustainable development include the recognition that the many crises facing the planet are interlocking crises that are elements of a single crisis of the whole world. Also, there is a vital need for the active participation of all sectors of society in consultation and decisions relating to sustainable development. The United Nations Conference on Environmental and Development, known as the Earth Summit, was held in Rio de Janeiro, Brazil from the 3rd through the 14th of June in 1992. This global conference, held on the occasion of the 20th anniversary of the first Human Environment Conference in Stockholm, Sweden in 1972, brought together political leaders, diplomats, scientists, representatives of the media, and non-governmental organizations, or NGOs, from 179 countries for a massive effort to focus on the impact of human socioeconomic activities on the environment. The Rio de Janeiro conference highlighted how different social, economic, and environmental factors are independent and evolve together, and how success in one sector requires action in the other sectors to be sustained over time. The primary objective of the Rio Earth Summit was to produce a broad agenda and a new blueprint for international action on environmental and development issues that would help guide international cooperation and development policy in the 21st century. The Earth Summit concluded that the concept of sustainable development was an attainable goal for all of the people of the world, regardless of whether they were at the local, national, regional, or international level. It is also recognized that integrating and balancing economic, social, and environmental concerns in meeting our needs is vital for sustaining human life on the planet, and that such an integrated approach is possible. The conference also recognized that integrating and balancing economic, social, and environmental dimensions required new perceptions of the way we produce and consume, the way we live and work, and the way we make decisions. This concept was revolutionary for its time, and it sparked a lively debate within governments and between governments and their citizens on how to ensure sustainability for development. The 2002 World Summit on Sustainable Development that took place in Johannesburg, South Africa, adopted a political declaration and implementation plan which included provisions covering a set of activities and measures to be taken in order to achieve development that takes into account respect for the environment. In doing so, this summit, which saw the participation of more than 100 heads of state and government and tens of thousands of government representatives and non-governmental organizations, resulted, after several days of deliberation, decisions related to water, energy, health, agriculture, biological diversity, and other areas of concern. In the area of water, the plan of implementation encouraged partnerships between the public and private sectors based on regulatory frameworks established by governments. With regard to energy, the need to diversify the energy supply was highlighted, as well as the need to add renewable energy sources to the global energy supply. In the area of health, the commitments made to fight against HIV/AIDS were reaffirmed, and the emphasis was placed on the rights of states to interpret the agreement on trade-related aspects of intellectual property rights in order to promote universal access to medicines. On agriculture, comprehensive negotiations on the World Trade Organization agreement on agriculture were envisaged, and these included market access, and reduction of export subsidies. With regard to biodiversity, the plan of implementation called for the establishment of an international regime to ensure fair and equitable sharing of the benefits arising from the use of genetic resources. The 2030 Agenda for Sustainable Development, adopted by all United Nations member states in 2015, provides a shared blueprint for peace and prosperity for people and the planet now and into the future. At its heart, there are 17 Sustainable Development Goals, which are an urgent call for action by all countries, developed and developing, in a global partnership. They recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, and spur economic growth, all while tackling climate change and working to preserve our oceans and forests. Here are a few examples from the 17 sustainable goals adopted by the United Nations. Number 1, no poverty. eliminate poverty by 2030, implement social protection systems for everyone, and create sound regional, national, and international policies that are pro-poor and gender sensitive. Number 2, zero hunger. End hunger and all forms of malnutrition. Double the agricultural productivity of small-scale farmers, the main source of food and income for many of the world's poor and hungry. Number 6 is clean water and sanitation. Provide access to clean water and adequate sanitation for all. Reduce water pollution. Increase the efficient use of water to reduce waste. Strengthen the ability of local communities to reach these goals. Number 13 is climate action. Produce national and international policies to reduce future climate change. Take steps to address climate change that has occurred or will inevitably occur. Establish a monetary fund to help developing countries respond. Finally, number 14, life below water. Prevent or significantly reduce ocean pollution. Sustainability manage ocean fisheries and ecosystems. Set aside at least 10% of marine areas for conservation. Increase the ability of small-scale fishers to sustainably use their ocean resources. Sustainable practices support ecological, human, and economic health and vitality. Sustainability presumes that resources are finite and should be used conservatively and wisely with a view to long-term priorities and consequences of the ways in which resources are used. In simplest terms, sustainability is about our children and our grandchildren and the world we will leave them. This includes sustainable agriculture where farming methods can be used indefinitely because they do not deplete resources such as soil and water faster than they are replaced. Sustainable development means present needs without compromising the ability of future generations to do the same. Sustainable energy from sources that are renewable and have low environmental impact. A sustainable fishery that ensures that fish stocks are maintained at healthy levels, the ecosystem is fully functional, and fishing activity does not threaten biological diversity. And finally, sustainable grazing practices that allow animals to graze in a way that keeps pastures healthy and allows grasses to recover. Sustainability science draws from a great variety of perspectives, including traditional and practical knowledge, ecology and economics, engineering and medicine, political science and law, and a multitude of others. These multiple perspectives are generally a source of strength, bringing potentially complementary bodies of theory, data, and methods to bear on the challenges of sustainable development. But they also have meant that the field remains somewhat fractured into distinct schools of thought, research programs, and other empires, each characterized by its own origins, terminologies, publication venues, case studies, and conceptual frameworks. Frameworks are usefully thought of as the most general form of conceptualization in science. They provide checklists or building blocks of elements and relationships for consideration in constructing theories or models that seek to explain particular patterns or phenomena. The concept of backcasting is central to a strategic approach for sustainable development. It is a way of planning in which a successful outcome is imagined in the future, followed by the question, what do we need to do today to reach that successful outcome? This is more effective than relying too much on forecasting, which tends to have the effect of presenting a more limited range of options, hence stifling creativity, and more important, it projects the problems of today into the future. In the context of sustainability, we can imagine an infinite number of scenarios for a sustainable society, and backcasting from scenarios can be thought of as a jigsaw puzzle in which we have a shared picture of where we want to go, and we have to put the pieces together to get there. However, getting large groups of people to agree on a desired future scenario is often all but impossible. Further, scenarios that are too specific may limit innovation and distract our minds from the innovative, creative solutions necessary for sustainable development. So, strategic sustainable development relies on backcasting from a sustainability principles which are based in science and represent something we can all agree on. If these principles are violated, our global society is unsustainable. To achieve a sustainable society, we know we have to not violate these principles. We don't know exactly what that society will look like, but we can define success on a principle level. In that way, backcasting from the principles is more like chess. We don't know exactly what success will look like, but we know the principles of checkmate, and we will go about playing the game in a strategic way, always keeping that vision of the future success in mind. A sustainable solution is long lasting, capable of being sustained, and is able to be maintained without exhausting natural resources or causing severe ecological damage. Sustainability solutions are designed to enable a better, safer, and more interconnected world. As sustainability grows in popularity, the definition of sustainability is expanding as well, giving rise to ESG investing. ESG, or environmental social governance, goes beyond environmental concerns and includes issues such as product safety, human rights, diversity and inclusion, succession planning, and anti-competitive behavior. Comprehensive sustainability solutions can support companies through the entire business lifecycle by measuring and identifying a company's environmental impacts and how those affect investors, consumers, the media, regulators, and other stakeholders. Environment and natural resources preservation is vital to the economic growth of any country or region in many ways, but also susceptible to the extent that their utilization, management, and sustainability can be affected by performance and deeds of various actions within the society. Natural resources and environmental issues matters are cross-sectional, but also renders input in every sector in terms of reducing poverty and destitute conditions of people, and therefore need to be accorded the highest precedence. There are two main kinds of resources responsible for shaping ecosystems: biotic and abiotic. The biotic factors refer to all living things presented in an ecosystem, and the abiotic factors represent all non-living components like physical conditions such as temperature, humidity, and sunlight, and chemical agents such as different gases and mineral nutrients present in the air, water, and soil. Therefore, both abiotic and biotic resources affect the survival and reproduction process. Furthermore, both these components are reliant on each other. Suppose if one of the factors is removed or altered, its repercussions will be faced by the entire ecosystem. Without a doubt, abiotic factors directly affect the survival of organisms. Natural resources are materials from the earth that are used to support life and meet people's needs. Any natural substance that humans use can be considered a natural resource. Oil, coal, natural gas, metals, stone, and sand are natural resources. Other natural resources are air, sunlight, soil, and water. Animals, birds, fish, and plants are natural resources as well. Natural resources are used to make food, fuel, and raw materials for the production of goods. All of the food that people eat comes from plants or animals. Natural resources such as coal, natural gas, and oil provide heat, light, and power. Natural resources are also the raw materials for making products that we use every day, from our toothbrush and lunchbox to our clothes, cars, televisions, computers, and refrigerators. Renewable resources are those natural resources such as trees, water, sun, and wind that can be replenished at about the same rate in which they are used. Renewable resources, however, can be depleted if not properly managed or conserved. Non-renewable resources are those natural resources that are depleted more quickly than they can regenerate. Fossil fuels like oil and natural gas were formed over millions of years. Once mined and used completely, non-renewable resources are gone forever. Earth's natural resources include air, water, soil, minerals, fuels, plants, and animals. Conservation is the practice of caring for these resources so all living things can benefit from them now and in the future. All the things we need to survive, such as food, water, air, and shelter, come from natural resources. Some of these resources, like small plants, can be replaced quickly after they are used. Others, like trees, take a long time to replace. These are renewable resources. Other resources, such as fossil fuels, cannot be replaced at all. Once they are used up, they are gone forever. These are non-renewable resources. People often waste natural resources. Animals are overhunted, forests are cleared, exposing land to wind and water damage. Fertile soil is exhausted and lost to erosion because of poor farming practices. Fuel supplies are depleted. Water and air are polluted. If resources are carelessly managed, many will be used up. If used wisely and efficiently, however, renewable resources will last much longer. Through conservation, people can reduce waste and manage natural resources wisely. The population of human beings has grown enormously in the past 2 centuries. Billions of people use up resources quickly as they eat food, build houses, produce goods, and burn fuel for transportation and electricity. The continuation of life as we know it depends on the careful use of natural resources. Water and air are critical natural resources that we cannot live without. The Forest Service strives to protect, maintain, and restore these valuable assets now and into the future. Water is one of the most important natural resources flowing from the forests. The Forest Service manages the largest single source of water in the U.S., about one-fifth originating from 193 million acres of land, which provides drinking water to 180 million people every day. Air is another critical resource for humans, plants, animals, and other organisms within a natural area. Air must be monitored in order to control and lower pollution levels, control smoke caused by wildfires, and to monitor air quality. The Forest Service monitors the effects of air pollution that may impair visibility, harm human health, injure trees and other plants, acidify or cause unnatural fertilization of streams and lakes, leach nutrients from soils, and degrade cultural resources like archaeological sites and historic buildings. Forest activities that can affect air quality, such as prescribed burning, ski areas, and mining, are also monitored to ensure compliance with air regulations for human health and to monitor possible impacts to natural resources. The most important things that land supplies for human survival are food, housing, and natural resources. Fertile land is necessary for growing crops because agriculture provides the majority of the world's food. Additionally, the land is used for forestry, fishing, and raising of cattle, all of which produce food. The land is utilized to construct homes, infrastructure, and other structures that offer protection from the elements because shelter is another basic human need. The land is essential for supporting economic activity. For instance, the use of land for forestry, mining, and agriculture can result in considerable economic benefits, including money and jobs. The land is also used for urban and industrial development, which can drive economic growth and create jobs. The land is seen as a valuable investment in many nations due to its potential for appreciation. The contribution that land makes to biodiversity and health of ecosystems is another factor in the importance of land as a resource. The flow of water and other resources that are necessary for life are supported by the land, which also offers a habitat for plants and animals. In order to prevent global warming and regulate Earth's temperature, the land is also essential. It does this by absorbing carbon dioxide from the atmosphere. Finally, due to the limited quantity of land, it is seen as a valuable resource. As the world's population continues to grow, the demand for land is increasing, and competition for resources is becoming more intense. This has led to land degradation, deforestation, and other forms of environmental degradation, which have negative impacts on both human and society and the environment. Simply put, deforestation refers to the purposeful clearing of forested land with the intention of converting that land into non-forest uses like farms or development. Deforestation is different from forest degradation, which occurs when a forest continues to exist but has lost its capacity to provide quality ecosystem services like carbon storage or goods and services to people or nature. Forest degradation can be driven by overgrazing, demand for wood products, fires, pests or disease, and storm damage. Large-scale commercial agriculture continues to be the main driver of deforestation, primarily for cattle ranching and soy, rubber, or palm oil cultivation. Another cause of deforestation is fires, which can occur due to either natural causes like lightning and drought or be man-made. Often, fire is purposefully used to convert forests into areas of agriculture. Scientists have been able to use satellite-based forest monitoring technology to locate where and why deforestation is happening. A study in 2018 found that 27% of all forest loss is caused by permanent land use change for the production of commodities, essentially land to grow long-term commercial crops. Even worse, the researchers discovered that drivers for deforestation remain constant throughout the 15-year study, suggesting that corporate agreements to curb deforestation may not be working in certain places. Forests provide habitats for 80% of the world's amphibian species, 75% of bird species, and 68% of mammal species, while 68% of all vascular plants are found in tropical forests alone. According to the UN Food and Agriculture Organization's 2020 State of the World's Forest Report, we lost about 420 million hectares of forests throughout converting to other land use since 1990. Though that number is believed to be decreasing, over 100 million hectares are also negatively affected by fires, pests, diseases, invasive species, drought, and other adverse weather events. Since forests act as carbon sinks, basically soaking up carbon dioxide and other greenhouse gases from the atmosphere that would otherwise contribute to climate change, they hold a large amount of the Earth's total carbon reserves. This means that when trees are cut down or burned, they emit carbon rather than absorb it, adding to the same rising temperatures and irregular weather patterns they are designed to curtail. The vicious cycle continues when species that rely heavily on forest ecosystems as a source of habitat and food are displaced due to climate change in addition to deforestation. The United States uses and produces many different types and sources of energy, which can be grouped into general categories such as primary and secondary, renewable and non-renewable, and fossil fuels. Primary energy sources include fossil fuels such as petroleum, natural gas, and coal, nuclear energy, and renewable sources of energy. Electricity is a secondary energy source that is generated from primary energy sources. In 2021, the electric power sector accounted for about 96% of total U.S. utility-scale electricity generation, nearly all of which was sold to other sectors. The transportation, industrial, commercial, and residential sectors are called end-use sectors because they consume primary energy and electricity produced by the electric power sector. Total energy consumption by the end-use sectors includes their primary energy use, purchased electricity, and electrical system energy losses. The sources of energy used by each sector vary widely. For example, in 2021, petroleum provided about 90% of transportation sector's energy consumption, but only 1% of the electric power sector's primary energy use. The chart below shows the types and amounts of primary energy sources consumed in the United States, the amounts of primary energy used by the electric power sector and the energy end-use sectors, and the retail sales of electricity by the electric power sector to energy end-use sectors. Let's take a look at the basics of what climate change is and how it is affecting the world. Weather is the mix of events that happen each day in our atmosphere. Even though there's only one atmosphere on Earth, the weather isn't the same all around the world. Weather is different in different parts of the world and changes over minutes, hours, days, and weeks. Whereas weather refers to short-term changes in the atmosphere, climate describes what the weather is like over a long period of time in a specific area. Different regions can have different climates. To describe the climate of a place, we might say that what the temperatures are like during different seasons, how windy it usually is, or how much rain or snow typically falls. When scientists talk about climate, they are often looking at averages of precipitation, temperature, humidity, sunshine, wind, and other measures of weather that occur over a long period of time in a particular place. In some instances, they might look at these averages over 30 years. The modern record of atmospheric carbon dioxide levels began with observations recorded at Mauna Loa Observatory in Hawaii. This graph shows the station's monthly average carbon dioxide measurements since 1958 in parts per million. The seasonal cycle of highs and lows, the small peaks and valleys, is driven by northern hemisphere summer vegetation growth, which reduces atmospheric carbon dioxide, and winter decay, which increases it. The long-term trend is rising carbon dioxide levels is driven by human activities. At Mauna Loa, the highest monthly value each year occurs in May. In May 2023, carbon dioxide hit 424 parts per million, a new record. Carbon dioxide concentrations are rising mostly because of the fossil fuels that people are burning for energy. Fossil fuels like coal and oil contain carbon that plants pulled out of the atmosphere through photosynthesis over millions of years. We are returning that carbon to the atmosphere in just a few hundred. Since the middle of the 20th century, annual emissions from burning fossil fuels have increased every decade, from close to 11 billion tons of carbon dioxide per year in the 1960s to an estimated 36.6 billion tons in 2022, according to the Global Carbon Budget of 2022. The greenhouse effect is a process that occurs when gases in Earth's atmosphere traps the sun's heat. This process makes Earth much warmer than it would be without an atmosphere. The greenhouse effect is one of the things that makes Earth a comfortable place to live. Sunlight, with the natural greenhouse effect process, makes Earth habitable. While around 30% of the solar energy, the light and the heat from the sun, that reaches our world is reflected back into space, the rest is either absorbed by the atmosphere or Earth's surface. This process, which is constantly happening around the globe, warms the planet. This heat is then radiated back up in the form of invisible infrared radiation. While some of this infrared light continues on into space, the vast majority gets absorbed by atmospheric gases, known as greenhouse gases, causing further warming. But higher concentrations of greenhouse gases, and carbon dioxide in particular, are causing extra heat to be trapped and average global temperatures to rise. For most of the past 800,000 years, much longer than human civilization has existed, the concentration of carbon dioxide in our atmosphere was roughly between 200 and 280 parts per million. But in the past century, that concentration has jumped. In 2013, driven up largely by the burning of fossil fuels and deforestation, carbon dioxide in Earth's atmosphere surpassed 400 parts per million, a concentration not seen on the planet for millions of years. As of 2023, it has reached more than 420 parts per million, which is 50% higher than pre-industrial levels. Carbon dioxide accounts for almost 80% of global human-caused emissions, and carbon dioxide sticks around for quite a while. Once it is emitted into the atmosphere, 40% still remains after 100 years, 20% after 1,000 years, and 10% as long as 10,000 years later. Some carbon dioxide is absorbed quickly, but some will remain in the atmosphere for thousands of years. Methane persists in the atmosphere for around 12 years, which is less time than carbon dioxide, but it is much more potent in terms of the greenhouse effect. In fact, pound for pound, its global warming impact is almost 30 times greater than that of carbon dioxide over a 100-year period. In the United States, methane accounted for more than 12% of human-generated greenhouse gas emissions in 2021. While methane can come from natural sources like wetlands, more than half of all global methane emissions come from human activities like natural gas production and livestock-based agriculture. Nitrous oxide is a powerful greenhouse gas. It has a global warming potential around 270 times that of carbon dioxide on a 100-year timescale and remains in the atmosphere on average a little more than a century. It accounts for about 6% of human-caused greenhouse gas emissions in the United States from sources like fertilizers and agriculture. Emitted from a variety of manufacturing industrial processes, fluorinated gases are man-made. There are four main categories: hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride. Although fluorinated gases are emitted in smaller quantities than other greenhouse gases, they trap substantially more heat. Indeed, the global warming potential for these gases can be in the thousands to tens of thousands, and they have long-term atmospheric lifetimes, in some cases lasting tens of thousands of years. The most abundant greenhouse gas overall, water vapor, differs from the other greenhouse gases in that its changes in its atmospheric concentrations are linked not to human activities directly, but rather to warming that results from the other greenhouse gases we emit. Warmer air holds more water, and since water vapor is a greenhouse gas, the more water absorbs more heat, inducing even greater warming and perpetuating a positive feedback loop. Let's switch gears a little and discuss invasive species and the value of biodiversity. An invasive species can be any kind of living organism, such as an amphibian, plant, insect, fish, fungus, bacteria, or even an organism's seeds or eggs that is not native to an ecosystem and causes harm. They can harm the environment, the economy, or even human health. Species that grow and reproduce quickly and spread aggressively with the potential to cause harm are given the label invasive. An invasive species does not have to come from another country. For example, lake trout are native to the Great Lakes, but are considered an invasive species in Yellowstone Lake in Wyoming because they compete with the native cutthroat trout for habitat. Invasive species are primarily spread by human activities, often unintentionally. People and the goods we use travel around the world in and very often carry uninvited species with them. Ships can carry aquatic organisms in their ballast water, while smaller boats can carry them on their propellers. Insects can get into wood, shipping pallets, and crates that are shipped around the world. Some ornamental plants can escape into the wild and become invasive. And some invasive species are intentionally or accidentally released pets. For example, Burmese pythons are becoming a big problem in the Everglades in Florida. Biodiversity is essential for the processes that support all life on Earth, including humans. Without a wide range of animals, plants, and organisms, we cannot have healthy ecosystems that we rely on to provide us with the air we breathe and the food we eat. And people also value nature of itself. Some aspects of biodiversity are instinctively widely valued by people, but the more we study biodiversity, the more we see that all of it is important, even bugs and bacteria that we can't see or may not like the look of. There are lots of ways that humans depend upon biodiversity, and it is vital for us to conserve it. Pollinators such as birds, bees, and other insects are estimated to be responsible for a third of the world's crop production. Without pollinators, we would not have apples, cherries, blueberries, almonds, and many other foods we eat. Agriculture is also reliant upon invertebrates. They help maintain the health of the soil crops we grow in. Soil is teeming with microbes that are vital for liberating nutrients that plants need to grow, which are also then passed to us when we eat them. Life from the oceans provides the main source of animal protein for many people. Trees, bushes, and wetlands and wild grasslands naturally slow down water to help soil to absorb rainfall. When they are removed, it can increase flooding. Trees and other plants clean the air we breathe and help us tackle the global challenge of climate change by absorbing carbon dioxide. Coral reefs and mangrove forests act as natural defenses, protecting coastlines from waves and storms. Many of our medicines, along with other complex chemicals that we use in our daily lives, such as latex and rubber, also originate from plants. Spending time in nature is increasingly understood to lead to improvements in people's physical and mental health. Simply having green spaces and trees in cities has been shown to decrease hospital admissions, reduce stress, and lower blood pressure. Let's talk about the most prolific issue when it comes to sustainability on Earth, and that is the rapid rise of the world's population and how to deal with it. Population growth is the increase in the number of people in a population or dispersed group. Actual global human population growth amounts to around 83 million annually, or 1.1% per year. The global population has grown from 1 billion in 1800 to 7.9 billion in 2020. As of 2023, there are now over 8 billion people on Earth. The UN has projected population to keep growing, and estimates have put the total population at 8.6 billion by the mid 2030, 9.8 billion by mid 2050, and 11.2 billion by 2100. However, some academics outside the UN have increasingly developed human population models that account for additional downward pressures on population growth. In such a scenario, population would peak before 2100. World human population has been growing since the end of the Black Death around the year 1350. A mix of technological advancement that improved agricultural productivity and sanitation, and medical advancement that reduced mortality rate increased population growth. In some geographies, this has slowed through the process called the demographic transition, where many nations with high standards of living have seen a significant slowing of population growth. This is in direct contrast with less developed countries where population growth is still happening. It is only logical that an increase in the world's population will cause additional strains on resources. More people means an increased demand for food, water, housing, energy, healthcare, transportation, and more. And all that consumption contributes to ecological degradation, increased conflicts, and a higher risk of large scale disaster like pandemics. An increase in population will inevitably create pressures leading to more deforestation, decreased biodiversity, and spikes in pollution and emissions, which will exacerbate climate change. Ultimately, unless we take action to help minimize further population growth heading into the remainder of this century, many scientists believe the additional stress on the planet will lead to ecological disruption and collapse so severe that it threatens the vitality of life on Earth as we know it. The scarcity brought about by environmental disruption and overpopulation has the potential to trigger an increase in violence and political unrest. We're already seeing wars fought over water, land, and energy resources in the Middle East and other regions, and the turmoil is likely to increase as the global population grows ever larger. Human population growth impacts the Earth in a variety of ways, including first, increasing the extraction of resources from the environment. These resources include fossil fuels, oil, gas, and coal, minerals, trees, water, and wildlife, especially in the oceans. The process of removing resources, in turn, often releases pollutants and waste that reduce air and water quality and harm the health of humans and other species. Next, an increase in the burning of fossil fuels for energy to generate electricity and to power transportation and industrial processes. The more people, the more we need to burn fossil fuels to generate electricity to fuel the cities they live in. It would also include an increase in freshwater use for drinking, agriculture, recreation, and industrial processes. Fresh water is extracted from lakes, rivers, the ground, and man-made reservoirs. There would also be an increase in the ecological impact on the environment. Forests and other habitats are disturbed or destroyed to construct urban areas, including the construction of homes, businesses, and roads to accommodate growing populations. Additionally, as populations increase, more land is used for agricultural activities to grow crops and support livestock. This, in turn, can decrease species populations, geographic ranges, biodiversity, and alter interactions among organisms. It would also require increasing in fishing and hunting, which reduces species populations of the exploited species. Fishing and hunting can also indirectly increase number of species that are not fished or hunted if more resources become available for the species that remain in the ecosystem. There would be an increase in the transport of invasive species either intentionally or by accident as people travel and import and export supplies. Urbanization also creates disturbed environments where invasive species often thrive and outcompete native species. For example, many invasive plant species thrive along strips of land next to roads and highways. Finally, it would intensify the transmission of diseases. Humans living in densely populated areas can rapidly spread diseases within and among populations. Additionally, because transportation has become easier and more frequent, diseases can spread quickly to new regions.